Hello everyone, my name is Nochvay and I'm security researcher at Kaspersky ICS. Today we are going to talk about CODESYS Runtime and let's begin. Let's begin with the intro. So for today, the use of pre-made software code in a product is a rule rather than exception. This enables the developers of a new product to avoid reinventing the wheel and the development of new product with this blank page. There is two kinds story when the product uses a library when the developers needs a specific function, for example, drawing images or saving the record to the database. And sending the files to the printer. In this case, the developer uses library. And there is another story when product uses a framework. The framework is a sophisticated mechanism that is already in place. And the developer's code must be designed to be a cog in such mechanism. It means next that so what's the main difference between them? First, the control of execution flow. When your product uses the library, your code is still big boss here, and your code dictates the rule of whole program. But when your product uses the framework dictates the rule for your code. And the framework says to your code when it will launch and when it will finish. So today we are going to talk about CODESYS Runtime framework. So today we are going to talk about CODESYS Runtime. It is a framework which has already been adapted for more than 300 software. 300 industrial devices, and here is our agenda for half an hour. We will talk about our object of research, CODESYS Runtime, the main aim of our research, protocol, about vulnerabilities, what we have discovered there, and at the end of the presentation we will sum up. So what is the CODESYS Runtime? CODESYS Runtime is a framework for creating industrial devices execution environment. It is not limited only PLC type devices. It is also used for one board computer, HMI, and soft PLC. For today, CODESYS Runtime has already been adapted for more than 360 devices, and I want to emphasize here 3 points. First, that CODESYS group has adapted only at least 20 devices by themselves. 20 devices from 360, it is less than 6%. Next, that it is only official information, and we know at least 6 companies at Russia which also uses CODESYS Runtime for their own devices, but these companies aren't included in this list. And the last one, that 4 years ago, the number of these devices was only 140. Today, it is 360, and I will not be surprised if this trend continues to grow. For CODESYS Runtime is execution environment, and for every kind of execution environment is needed a development environment. CODESYS group created his own development environment, which is called CODESYS development system. In context of our research, it's important that CODESYS development system is customizable development environment, and a lot of companies created, based on this solution, their own solution. So, what is inside the CODESYS Runtime? CODESYS Runtime based on component-oriented architecture. It means that each logical or functional part is divided by one or more components. So let's take building, Lego building as an analogy. So this building consists a lot of small bricks. Each of these bricks is responsible for something. For example, here is a door, window, bird of prey, and so on. And this brick, for CODESYS, it is a component. The same components of CODESYS is responsible for something. For example, communication with files, sockets, schedule, and so on. We can group them by their group of responsibility. First, component manager is the main of these components that launch all other components. Network components for responsibility communication with outside, with all world application for controlling application or program on the PLC, and there is hidden core components, group components for controlling PLC or industrial devices. So, as I said, component manager is the main of components. Is the main of components that launch all other components. So it's kind of init process from the Linux world, and very good question how it works, how it communicates with other components. So each of these components must include a set of functions or interface. And here is the function initialization, export, import, event handling, and so on. So again, analogy. Here is the brick of Lego. This cylindric things is called stat. The stat attached to the tube, the element of bottom of detail. So we can say that stat is element of export, and tube is element of import. So they put together one by one and build the building. So component able to register his own function as export function, and then other components can import these exported functions and use it. So this is how it works. And the payloads of component, it is the body of Lego bricks. The payload of components contains an event handling function. So component manager determines what kind of events happens in PLC or industrial devices in current time, and then call this function for each of components and send this specify events to them, and then company decides what to do. So another important question: what does it mean to adapt CODESYS runtime for selected hardware or selected operation system? The developer is responsible for creating for development system components. So this system components is responsible for low level operation with the system, with hardware, with operation system, and so on. So adapted CODESYS runtime has to know how to work with memory, with heap, with file, with graphic, and so on. As I said before, CODESYS group has adapted only 20 CODESYS runtime for different devices, and there is two adaptations: one for CODESYS one for Raspberry Pi, and one soft PLC, one adaptation for Linux as a soft PLC. So let's talk now about the state of the executable files, and there is a lot of interesting things. That first, both of these files are packet, and when CODESYS runtime runs, it unpacks in insecure way. So after the unpacking, CODESYS Runtime opens one big point that leads to exploitation of binary vulnerability easier than it could to be. And the second thing that these two files were complete without any additional security options like ISLR, ZEP, SEG, and so on. So it is so easy to exploit binary vulnerability in CODESYS if you find it. And other things that CODESYS Runtime contains a lot of different components to improve security of the system. For example, security communication, integrity, checking integrity of fields of application, user management system, but all of these components are disabled by default. Last thing that by default there's kind of maybe 10 threads and 6 network services, and all of this stuff run as one process. So if somewhere crash, then will crash anything, will crash the other things. And yes, daemon of CODESYS Runtime in Linux run with root privileges, the hide privileges in the system, and emulation, and the soft PLC for Windows also runs with the hide privilege in the system, so with the system privileges. So let's now change the theme of talking and talk about protocol, what we have investigated here. So first, this protocol is called CODESYS PDU or Packet Data Unit. It is not limited only for network communication. It is also used to communicate over USB, over CAN, bus, and serial ports. CODESYS PDU is based on ICOC model, and as ICOC model, it contains a few layers: block driver layer, datagram layer, channel layer, and services layer. So it is not just a protocol, it is a stack of protocols. For example, let's take, for example, here is our packet was sent from the CODESYS development system to CODESYS Runtime to authenticate it. So this packet contains command to authenticate login and password. If we parse this packet, we will get a real beast with enormous amounts of packet, enormous amount of fields. So, for example, here, this byte is a binary mask or binary structure. It means that this byte contains more than one field itself. Other fields, for example, this one, not this one, this one determines the remaining size of the packet, and so on. Next, I will tell you a few facts about CODESYS PDU protocol, and I will begin with the architecture. With the architecture of this protocol, that CODESYS PDU protocol is based on ICOC model. CODESYS Runtime always uses the capabilities of operation system and drivers which is adapted. So it means that the resultant packet of which was sent over, for example, TCP, will contain two stack protocols. First, TCP, which is based on ICOC model, and CODESYS PDU, which is also based on ICOC model. So it is quite interesting. Next, fact that more than 10 components process the network packet. Here's our first layer, block driver layer. Block driver is just creating the capability to communicate over physical interface like Ethernet or CAN bus and so on. Next layer is datagram layer. He's tasked to route packet to network discovery, open the network discovery service, and transmit the remaining data to the next layer. Next layer is a channel layer. He's tasked to create a synchronization in communication, checking integrity of communication, and transmit the remaining data to the last service, to the last layer. The last layer is called services layer. His task is querying the specify service in this packet. Also, it is used to encode, decode, decrypt, encrypt, and this kind of stuff. So, as I said before, first layer is a block driver layer, and here's one interesting thing that block driver component is a kind of input point and for incoming messages and output con for outgoing messages. And some of these components, for example, block driver component for TCP, adds additional fields in the packet. For example, here we have a magic string and the size of remaining data with one plus the size, his own size, and plus the size of previous field. That's really strange because field must know his own size, but it works like this. And next one, fact that CODESYS PDU contains kind of addresses of sender and receiver. So here, CODESYS Runtime works with two types of addresses, relative and direct. So here is an example of direct addresses. Here we have 2 bytes of port and full IP version 4 addresses, like in IP protocol somewhere. So this is type of direct address, and here is the type of relative addresses. Instead of 4 bytes of addresses, we have only 1 byte of relative addresses. So what does it mean, sender and receiver? So why here we have only 1 byte instead of 4 bytes? CODESYS node, which includes CODESYS development system and CODESYS runtime also, use kind of tree network topology. So each of higher nodes associated with the lower level nodes, and these low level nodes contain the address of his parent here, and this is how one node can reach other nodes, even these nodes work with a different physical interface. Next fact that components able to register his own handler as a service, and there is one rule that one component can register only one service at the last layer. And here, if you were used CODESYS Runtime at once, you saw that CODESYS development system and CODESYS Runtime can communicate together over encryption channel. So how it works? You open CODESYS development system, then you connect to CODESYS Runtime, open PLC shell, generate certificates, keys, and so on. Then you again open CODESYS development system and choose make me encryption type of connection, but it means that this encryption connection isn't fully encrypted and it will be never encrypted, because the encryption of CODESYS Runtime that they development means that only last layer, services layer, will be encrypted. All previously data like sender address and sender address and receiver addresses will never be encrypted if you use the encryption of CODESYS, the encryption created by CODESYS. So this all, it was all facts that I wanted to say, and now let's take the now let's talk about the vulnerabilities. If you're going to find vulnerabilities, you always need a plan, and we split our plan for 3 steps. First, we know that CODESYS PDU protocol is based on ICOC model, and we can presume that this model of ICOC CODESYS PDU also inherited the shortcomings of model ICOC. So this is our first step and our first way how to find vulnerabilities in CODESYS PDU protocol. Second, we know that CODESYS development system compiles application for adapted devices with which CODESYS Runtime runs as a native code of processor. So we have a very good chance to find places where we can inject our own code instead of application. I mean our shell code instead of compiled application, and just run our own code. And the last one, that CODESYS Runtime is closed source protocol, so it is always hard to create a quality fuzzing it is always hard to create quality fuzzing without source of application, but we adapted a fail. It is kind of one of the famous fuzzing for CODESYS without any source code, and we run continuous fuzzing with returning path for CODESYS Runtime, and we will write something about this for security researchers. I hope so. So next I will talk about a few vulnerabilities what we have discovered. First, it is similar. First vulnerability is address spoofing. It is very popular threat for IP protocol. So if attacker wants to hide his address from victims, he will change the address of CRC or the address of source, his own source, and the first victim, when it takes the packet, will send the response to the source or to the nodes from IPCRC. So it's kind of way how to hide your own IP address in the network. It is obviously that we can implement the same attack on CODESYS PDU protocol if we change the sender and receiver fields. I remind you that the sender fields refers to address to which the message must be sent, and receiver refers to the address for which the response must be sent. So here we change receiver fields, the address in receiver fields, and created kind of classical IP spoofing attack. So it was pretty easy, but then we know that on one task of the datagram layer is to route packet, and if this packet And if this packet, if this node catch the packet and see and understand that the sender address isn't the same as his own, he will transmit the packet to another address, which is the same with the sender value. So it's kind of how to use one additional node as a proxy and make the type of attack IP spoofing is harder to understand and harder to investigate. Yeah, but there is one more additional kind of piece of cake that CODESYS, that component block driver for UDP connection listen the broadcast messages and able to send the message to the broadcast. So we can send the packet and set up for receiver fields broadcast address, and then the victim PLC catch this packet. It will send the response to the broadcast and attacker, and with scheme of attack, the attacker able to gain the result or response from the victim without direct interact with the victim. And yes, the attacker can use, instead of one proxy nodes, a few proxy nodes, because CODESYS Runtime is very trustful and believe in the data that it receives. So from the point of view with victim nodes, he thinks that broadcast addresses connected to him, requested open channel, and send kind of and started the communication. That's very funny. And from the last vulnerability, we can the very good question: if there is existing communication between two nodes, will attacker possible to inject or to send injection packet in an existing channel of communication? So it is obviously then yes. So it's kind of snake with malicious packet here with node received CODESYS PDU packet. Also check that this is not his address in receiver and just transmit it. So it's very fine. And next vulnerability, we found Meetum by design. As I said before, that CODESYS the network topology of CODESYS node is a tree topology, and we try to find kind of a mechanism of functionality the similar as IRP table. And here's what we found. We found one services which is called address services. These address services use it to change the addresses of CODESYS nodes in dynamic way. So if the attacker sends special request to the nodes will change his own addresses, and then each of outgoing traffic from these addresses will be sent to the attacker nodes. So it's kind of Meetum by design. And I remind you that component for communication over UDP listens broadcast addresses, and this special packet can be sent to the broadcast addresses, and each of nodes in the network will change their own addresses and set up the attacker addresses as their parent addresses. So it is kind of massive MITM. So what we can do with MITM? Of course, we can do a lot of bad stuff, and one of this bad stuff is we can decrypt the transmitted password. So here's our pseudocode. Of course, on this string we can see that cyclic SOR with fixed K. That's also very bad. And how does it work? Here is our login administrator and encrypted password. In 21st century, CODESYS group decided that SOR with fixed K is enough to provide security for transmitted password. And here we can see some of symbols of transmitted password. So it is default password for administrator, and it is obviously that default password for administrator is administrator. That is also very bad. Next vulnerability. It is the next step, as I said, the vulnerability of application code. We wrote a simple program for PLC. We wrote a simple program for TCP and for CODESYS Runtime, and set two magic string, one of them deadbeef, second beef, and then we compiled this program, sent to the network, and tried to find the mention of our magic string in the network. We found two places, one places with beef and one places with dead beef. Next, we put all this traffic in static analyzer and discovered that this mention contains assembler code for IRM process, because we sent this program to the CODESYS Runtime for Raspberry Pi. So here is the assembler code, and if you analyze it, you will get that it is just declaration of global variable. So it is the header of program, and the next mention. Here you can see add comment, and it is just a body of our program. So instead of this assembler code, we can put our own shell code, and we did it, and we got a proof of concept for this vulnerability, and that's it. So conclusions. We spent a lot of time to discover all this vulnerability and to understand how this protocol works, and we spent a lot of time to route tools and proof concept, to write report to the CODESYS group. And as sum up, I want to say that all this vulnerability could have been discovered by the community, security commission, I mean us, if protocol description had been available. So the approach, security by obscurity, in 21st century doesn't work, and we have seen a lot of example of this term. So this is all I wanted to say. We published a paper regarding this, regarding our research. You can find this paper here. And this is kind of Easter egg by CODESYS Runtime. If you run if you run CODESYS, if you run the executable file CODESYS runtime with a lot of verbose argument, it will show the call which is thank you by so I'm thank you for coming, and thank you for coming to my presentation. Thank you very much.
Thank you.